Algebra 2, this is the second part of target 26. I can sketch the graph of any exponential or logarithmic function. In today's video, we'll be looking at logarithmic functions and translations of those. So you already saw how to sketch a basic logarithmic function back in target 25. So today we are focusing just on the translation of that. Okay, we already know what a translation is because we saw translations of exponential functions yesterday. All right, so idea here, okay, you can graph a logarithmic function of the form y equals log base b of x minus h plus k, okay, by translating the graph of the parent function y equals log base b of x. All right, so again, just like yesterday, we are going to be adding h to all of our x coordinates. Okay, we're going to be adding we're going to be adding k to all of our y coordinates. All right, so again, looking at the changes this makes to our graph. Okay, so if you think back to a basic logarithmic function, this is just the inverse of an exponential function. So the points that we plotted, okay, we're just a over b negative 1, right? Just switching the x and y from the exponential. And then a0 and ab1. So again, to translate it, we're just adding h to all the x's, and we're adding k to all of the y's. Now, because the asymptote of a logarithmic function is a vertical line, how that changes this time is it's no longer the y-axis. It's going to be the line x equals h. So if we get into some examples, the first one we have is y equals log base 2 of x plus 3 plus 1. So again, you want to identify your values of b, h, and k. Notice that when we do logarithms, a is almost always equal to 1. So we don't really, excuse me, we don't really think about what a is. We don't care because normally it's just going to be 1. All right, so here it is. Okay, a is 1. It's right in front there. Okay, your base is b. Okay, again, this is going to be h, but it's going to be the opposite of what's shown. So it'll be negative 3, and then this is k. All right, so coming up with your values that we're going to plot for x and y. Right, so for x, we have a over b. So that's 1 over 2, and then plus h, so minus 3. Our second point is just a, which is 1, plus h, which is minus 3. And our third x coordinate will be a times b, so 1 times 2, which is 2, plus h, which is minus 3. Then our y coordinates for those points, we'll start out with negative 1 plus k, and then 0 plus k, and finally 1 plus k, so 1 plus 1. So the points that we're going to plot, okay, simplifying what we've got here, 1/2 minus 3 is negative 2.5. 1 minus 3 is negative 2, and 2 minus 3 is negative 1. Y coordinates are 0, 1, and 2. And our asymptote is going to be the line x equals h, which is negative 3. All right, so drawing the graph, start by graphing your asymptote. X equals negative 3 is the vertical line over here at negative 3. And then plot those points. So start with negative 2.5, 0. So negative 2.5, 0 will be right here on the x-axis. Then negative 2, 1 will be right here. And then negative 1, 2 will be right here. So what we're going to have is it's going to come up along the asymptote and then curve out through those 3 points. And there's the graph of our logarithm. Moving on to a second example. Again, the first step is to identify B, H, and K. So here's B. H is going to be here, and again, since it's minus, okay, it will be 3. And there is no K, it's plus 0. Okay, so that's K. And again, A is what's multiplied in front here, which is just 1. So, coming up with our points that we want to plot. Start with A divided by B, so 1 divided by 1/3. And then add H to that, so plus 3. Then A plus H. And then A times B, so 1 times 1/3 will be 1/3 plus 3. Our y coordinates start with -1, add 0, then 0 plus 0, and 1 plus 0. So the points that we're going to plot will be 1 divided by 1/3 is 3, plus 3 is 6, 1 plus 3 is 4, and 1/3 plus 3 is 3 1/3. Down here we'll just have -1, 0, and 1. And our asymptote be the line x equals h, which is 3. So graphing it, start by plotting your asymptote. Vertical line here at 3. Then plot the points. 6, -1. So we've got, let's see, 4, 5, 6, -1 is here. 4, 0 is here. And 3 1/3, 1 would be about right here. So our graph this time is going to come down along the asymptote and then curve out through our 3 points like this. Okay, and one final example. Okay, here f of x equals log base 4 of x plus 1 minus 2. So start by identifying a, b, h, and k. So again, a is trivial, it's almost always going to equal 1. B is 4. H this time, because it's plus 1, this is B. And h is going to be -1, and then minus 2 is your k. So setting up our points, x and y. Okay. For x, we have a divided by b, so 1/4, plus h, so -1. Then a plus h, and a times b, which is 4, plus h. Our y coordinates, -1 plus k, 0 plus k, and 1 plus k. So simplifying those, we have 1/4 minus 1 is going to be -3/4. 1 minus 1 is 0, and 4 minus 1 is 3. And our y coordinates, we've got -3, -2, and -1. Our asymptote this time, again, will be the line x equals h, which is -1. So start by drawing that asymptote. X equals -1. We have the vertical line here at -1. And then our points, plotting those, we've got -3/4, -3 is right about here. 0, -2 is here. And 3, -1 is about there. So our graph comes up along the asymptote and then curves out through our 3 points. And there's our graph. So, quick summary again for the steps of graphing any logarithmic function. Identify those values of a, b, h, and k. Right, a is almost always equal to 1. Again, be careful with h. Identify your asymptote, which is just going to be the vertical line, x equals h. And then again, plot the 3 points, adding h to each of your x coordinates, adding k to each of your y coordinates. And then we have the kind of reflected J-shaped curve. It's actually more like this now, right? All right, and that's all there is to it. That's graphing a logarithmic function. Okay, that's been translated. That'll be it for target 26. Okay, next we'll move into target 27, which deals with solving equations, exponential equations and logarithmic equations.